as if it is a unicast based protocol, right? So that's another interesting thing. Now we'll probably move on to the last section of the discussion, which is filtering the routes, right? Let's say I want to filter the routes. How would I do that, right? So actually to do that, let me just clear out my topology once again, because I've done a bunch of stuff here. So let me stop this. So I'm using the Eve emulator here, a community version of it. So I've stopped them. Probably let me start them again. Yeah, so all of them are up. Now you can look into my R1. It takes a minute to come up, I guess. So what we are looking into now is trying to, okay, that's good. So it's up, right? So show IP interface brief. Yeah. So the last section we are actually looking to filtering, right? Filtering of routes. What if you have a use case where you want R1 to receive only specific routes and you don't want R1 to receive all the routes, right? Via RIP. Let's say R2 is advertising a lot of them, but you want R1 to receive only specific of them. So that's where we try to bring in this concept of filtering the routes. You can do it via two ways, ACLs and prefix list. You'll probably see both of them, right? Let's start with R1. So we have R1. Again, let's go back and enable RIP on this. Do this again so that it will be a good practice for you guys as well. Router RIP, no auto, right? Let's also put version 2. The network is going to be 10.0.0. Other one is 10.11.0, right? That's done. R1 is good. So wait on R2 as well. Enable show IP interface brief. Okay. Configure router RIP version 2, no auto summary, network 10.0.0.0, network 192.168.23.0. Good. We could quickly check if we have everything, right? You can do show IP route. There you go. We are getting, okay. Not yet. We have not received the routes from R1 yet. To RIP, all of this looks good. Let's clear IP route. Yeah, so we have the routes from R1 now. So R1 and R2 both are good. Let's move on to R3. Figure router RIP and version 2, no auto, and the networks which I have to advertise here would be 34.0, I think 23.0, 3.0. Okay, so here it is with 172 and 16.0. 16.0, yeah, that should take care of everything, right? Great. So we're done with R3 and let's do yeah, that's good. So let's look on R1 now. What I want to show you guys is do this thing, show IP route, right? So when I do a show IP route, what you see here is that we have routes 172.16, 4.0, 5.0, 6.0 and 7.0, right, from R3 coming in here, right? So we have the routes, all these routes are seen on my R1, but my use case is that my use case is that I don't want all these routes to be seen on R1. Instead, I want the ones which have the third octet as the even number, right? So I want the 4.1 and 6.1, but I don't want 5.1 and 7.1 to be seen on my R1, right? So that is my use case. How will I accomplish this, right? So that's what we are trying to do. Okay, so let's, I already have the addresses here, and I'm trying to concentrate on my third octet, right, which is this one, 4, 5, 6 and 7, right? So now if you look at the binary representation of octet, how is it? 128 64, 32, 16, 8421, 211. Yeah. So these are your decimal values, or decimal yeah, the decimal values of each of the binary bit positions, right? And let's concentrate only on the third octet. Now I want my use case tells me that I want the third octet to be a even number, right? Any octet is a odd number when the last bit is 1, right? Because if you add all of this, you get 255, right? And basically, if you want this whole number or a whole octet to be a odd one or odd number, then your last bit, right? So this bit has to be 1, right? That's how you can get a odd number. So it only depends on this bit. The rest of the bits I don't care, right? The rest of the bits has no this thing. So basically in a ACL, what is the thumb rule of ACLs? If you want a particular bit to be checked, you use the 0, or you don't want a bit to be checked, you use the 1, right? It's basically a wildcard mask. So what I'm going to do is, I don't want the first bit to be checked, second, third, fourth, fifth, sixth, even the 7th one. I don't want all these bits to be checked, but I want the last bit to be checked, right? So this is how you write the ACLs, right? So this is going to be my third octet now when I'm writing my ACL and the mask, right? So let's write the ACL. Let me show you how we can write the ACL. Let's go down to R1 and write the ACL first. So you'll get to know what I'm trying to do. Access list 1, deny. I'm going to deny. What I'm going to deny, I want to deny all the even routes, right? So for the even routes, I want not just 4 and 6, but I want everything in this subnet, all the even routes to be denied. So what is the first address? It is 172.16.1.0, right? This is my first address. Now I want all my like I said, my even routes to be denied. So this is going to be my mask. My mask is going to be 250, sorry, it's going to be 0, because it has to match the first octet, it has to match the second octet, like we discussed. It's an ACL, it's wildcard mask. So whenever you want something to be matched, you use the 0, right? And in my third octet, like we decided, this is what we want to match only the last bit, right? So this is what you get out of that. So when you see the decimal equivalent of this, it's 254, right? And the last one is also going to be, it's going to be all ones, so it's 255. It's not relevant to me, right? So I just want these things to be checked so that the access list is applied. Right now, this is not sufficient. I need to also put in an access list for permitting the rest of the routes. Let's do a permit any. Done. What do we do next? Let's go down to router rip, right? Use the command distribute list here. Distribute list, access list name. In which direction? The inside direction, inbound. On the interface, 0/0, right? Clear IP route for a minute, clear everything. Show IP route would give me, now you can see the magic. You can see there are only even routes mentioned here, right? So what we did was, earlier we had even and out routes, odd routes, but by using ACL we actually denied all the odd routes and we just have the even routes now. Great. So another topic which I want to touch upon is the prefix list. So what if you want to do something similar using prefix list, right? So there is a difference. Access list basically, give me a second, right? So the access lists only help you to match the network person and not the subnet mask, right? So in this case, what we did was, we were able to match, do any kind of things, you can match any of the bits, but only the network section of it, right? But what if you also want to block certain routes based on their subnet mask as well? So that's where your prefix list comes into play. Okay, so for that, let's try that. So the prefix list is a kind of like it allows both the things. It allows you to match based on your network as well as the subnet mask. Okay, let's look at a example that will be helpful. So let's go down to my R3. look at the screen. If I do show IP interface brief, okay, I would probably want few more. So let's put in, let's go down to R3. So we have some, okay, this is here, great. So we'll probably pick in these. Okay, let's put these loopback addresses here. 151 4.1 32 64 96 112. Make a note that I have basically changed the subnet mask of all of them, right, to explain the example, right? So let me go down and clear this once again. Let's go down to router rip, and what do we do next? We're gonna put in the network. Which network? It's 150 network, right? This is sufficient. Great. So if you do now show IP route, probably, or probably we could show IP interface brief. So basically, if you look at the show IP interface brief, you can see the various loopbacks which I have enabled, which is good. Let's go down to R2. Let's see if your routes are basically visible here. Right? So I can do show IP route. Great. So you can see the routes appearing here. You can see the routes appearing here. See the routes. It basically says we have 150.1./22, 23, 24, 25, 26. Right. So I wanted to explicitly have this irregular subnets to show you or explain this example to you guys. Right. Great. So what are we trying to do now here? Let's say on my R2, I want to block all the I want to block the network 150.1.0.0, all those networks which have a mask which is equal to or greater than 24, right? So we have 22, 23, 24, 25, 26. I want to block these three routes on my R2, right? So that's what we are trying to accomplish, right? So let's go down to R3 and put in this prefix list. So for the prefix list, we say IP prefix list, put in a name, deny the network, which is 150.1.0.0/16, some major network. We use greater than or equal to. This is corresponding to the mask, right? Just like in your access list, you need to have a permit any statement at the last. But here you don't have something called as permit any. So in that case, we use something like this, right? We use the we basically create our own hack for this, which is 0/0/0.0/0, right? And you can say less than equal to or greater than 0 as well, but I would say less than equal to 32 is good, right? So this basically this statement translates into permit IP any, okay, which is good. Now let's go down to my router rip called the distribute list, which we did earlier. Distribute list, you call prefix, the name of that, and which interface? It's out, but I think the interface is basically 0/1, if I'm not wrong, right? So once we do this, let's clear the routes a bit, and let's do this again. Look at the changes which we have seen in the networks. You can see the changes here. We have stopped receiving the routes for those guys which have a mask, subnet mask greater than 24, right? Now we have just 22 and 23. Earlier, before applying the prefix list, we had 24, 25, 26 as well, right? So that's how you can use prefix list, and that's the difference between using access list and prefix list for filtering the routes, right? Cool. Let's go down to the last piece of this discussion, where I want to touch upon what we call as the offset list. Okay. Going back to the diagram, offset list allows you to an ability to add costs to routes to make slower routes less preferable, right? So what does that mean? If I look at the topology here, R4, R5, R6, let's make the links between R4 and R5 the fastest, right? These links are going to be faster than the link between R5 and R6, right? And then I will explain to you what I am trying to do, right? So let's go down to R4 probably. Let's go down to R4. clear screen, enable show IP interface brief, right? Enable RIP on this, router RIP, version 2, no auto, network 192.168.34.0. Other one is your network 10, right? And that was R4. I also will go and make certain things on the interfaces as well. So R4, I'm going to make S1/0. So this is serial interface 1/0. The bandwidth for this is going to be 15444, and the other interface is probably 2/0. I'm going to make the bandwidth for this a little slower, which is 512. Okay, so that's done for R4. Let's go down to R5. Show IP interface brief. Configure router RIP version 2, no auto, network. You have the 10 network. You have the 205.16.4.0, 5, 6, and 7, right? So if I clear the screen and do a show IP route, you can see the routes coming from everywhere. Great, so that's R5. Let's move on to R6. Did I see the 4.4 here? Yeah, good. Let's do R6. So on my R6, I'm going to do put in the network, which is 10. That's good. I think that should do. Did I also do the interfaces on this one? I think I did not. Okay, I did not put in the interfaces. I did not put in the speeds. So let me do that as well. So if you look at the diagram, R5, the serial interface 1/0, that's going to have a speed of I don't know, 1544. Okay, it's bandwidth. And the other interface, which is probably the serial interface 1/1, right, is going to have a speed of 128, right? So this interface is the slowest. This is 1544, this is 512, and this is 128. Okay, the last one is where I was doing the R6 one. So if you see here, the interface, we're looking to serial 2/0. This will be bandwidth 512, interface serial 1/1, and the bandwidth for this would be 128, right? That's done. Great. So now let's look into my R6. What has happened on my R6? If I do a show IP route, right, and if I just include what is happening on my 10.5, just want to see here. Okay, so I don't have anything yet. Let's look into show IP interface brief. Do we have a 10.5.5 route here? Okay, we don't have, that's why. Let's put a loopback address here. Great. So that's good. Let me just clear or flush the routes here. I'm just setting up all of this just to explain the concept. Yeah, there you go. Now what's happening is, from R6, if you want to reach my R5, right? From R6, if I want to reach my R5, the shortest path is 10.56, right? Via this particular, so directly connected, so serial interface. But also remember that this is the slowest path. I have given the speed of this link as 128, whereas these links have 5112 and 1544 as the speeds. So what if I want my routers to pick this particular path instead of picking this particular path, right? If I want my routers to forcibly pick the other path, it won't actually, because this path has a hop count of 2, whereas this path has a hop count of 1, right? And RIP basically uses hop count as the metric. But what if I want to force this guy to use the other two paths? So that's where we use the offset list, right? So how do we do that? You go down to my R6, router RIP, offset list, right? Put in a question mark and you can see that if you use a 0, it means that you are applying this offset list for all the networks, for all the routes which are advertised, right? So all the routes which are advertised on that interface. So I'm going to do that. I'm going to put a 0. Now I'm basically I can do either outbound and inbound. I'm going to do inbound first. I'll have to do the outbound as well. Just doing it in one direction is not sufficient. You have to do it on both the direction. So I'm saying offset list 0, all the routes which are coming inside on which interface, I mean how many hops do I want to add, right? So if you want the router to take this path, then the hop list which you need to add. So what we are doing is we are basically trying to, in simple terms, what we are trying to do is the routes which are coming in from R5 along this path, we are basically adding an extra metric or extra hop count on that, so that this router will from now on take the above path, right? So this one currently has 2 hop count and this is 1. So I need to add at least 2 hops for this particular path for this router to force taking this path, right? When I add 2 over here, the hop count here becomes 3 and here it still remains as 2, and that's why R6 will pick the top path, right? So that's what you're trying to do. So we'll add a hop count of 2 here, which is good. On which interface? Serial interface, but it is 1/1. There you go. That's it, done. So if I do I'll also do it on the inside direction as well, sorry, outside direction, because you need to do the same thing for all the routes which are going out as well, right? Inside and outside. Now what happens if I do a clear this thing, and if I see this, you can see here, see the clear difference. Earlier it was taking the 10.56 route, now it is taking the 10.46 route, because this one has a hop count of 2, whereas we have forcibly made the other guy to have the hop count of 3, right? So that is basically the concept of offset list, where you forcibly want a router to choose a different path from the optimal path which the RIP algorithm has chosen, right? And you have to do it on both the direction. You have to do it in this direction as well as the other direction, otherwise it won't work, right? So that's it, guys. That was a quick review of all the concepts which I revised on the protocol RIP. Do tune in for other videos as well. Thanks. Bye.